here we are trying to factor. When we get into bigger expressions, like a cubic equation, we really do want to be able to break these down into perfect factors. So some of the ideas that we've been working towards is that this cubic ideally will be able to split its degree where there's going to be an x in every degree combining to that cubic power. And so we're looking for perfect factors. So all those things that I like to say, that these have to be the perfect factors. Which means a perfect remainder is equal to 0, which is also going to mean that with these, we're going to be essentially finding the roots or the x-intercepts of this equation. And especially in this topic, we're going to be nice. We're going to say, well, I think this is 1. And is this 1? Which is kind of part of the remainder theorem that we can. And so before I divide, I'm just going to make sure my division would be kind of effective, as I use P of 5 to say, well, is that a factor? Is 5 an x-intercept? And I do believe we're in business. I do believe if I go 2 times 5 cubed, 9 minus 5 squared, minus 8 times 5 plus 15, I promise you it is going to give us a perfect remainder of 0, which means division should be okay. Now, in a synthetic division strategy, we generally set it up where we only focus in on the coefficients. Long division would really take a look at the degrees and making sure all the degrees line up. But in synthetic division, we're only going to rate the coefficients. Now, it is really important that these coefficients are in order, perfect descending order. It is really important that they count down. If there's a degree missing, we would have to deal with that and put it back in. We do have to have a perfectly lined up polynomial for this synthetic division to be effective. Now, I am going to be matching this idea that P of 5 ended up being 0, and I'm going to be dividing by that 5 as well. Same thing. If this ends up being a factor, a perfect factor, then 5 will be the root, which is what we end up dividing by. Now, in a synthetic division strategy, always get the first part of the answer for free. What we're going to be drilling down here, the quotient, is my answer. So we always get the first one for free, and then we perform a 2-step algorithm. Multiply these two to get the next number. Add these two to get the next part of your answer. Multiplies, adds, multiplies, adds. And as promised, the last number we get in our division is always called our remainder. And from that remainder, we would be able to interpret this as this is the constant, this is the degree 1 term, this is the degree 2 term, and so on if it was a bigger division. So successful. Yes, x minus 5 does belong in this list of perfect factors. And so a division statement would show exactly what's happening here. So in the division statement, which is called dq plus r, effectively, well, we just figured out that there's no remainder. So the only thing that it's going to show is that we factored the polynomial. And I'm going to keep my statement equivalent here. So this means that 2x cubed minus 9x squared minus 8x plus 15 did indeed split into the perfect factor x minus 5, and in the quotient, we got 2x squared positive x minus 3 constant. And we were able to now split this up. And this is exactly what factoring looks like. We took out 1 degree, we're still left with 2. Notice I still have 3 total degrees. Things don't just disappear. Cubics don't just turn into quadratics. We're keeping all things equivalent, keeping account of the whole expression. And then I would think we got to factor some more. And because it's now only the degree 2 piece that I'm factoring, we've got all sorts of strategies: sum product, decomposition, guess and check, and I mean, I could even use synthetic division again. But any good logical factoring strategy should complete this question. And so in my books, 2x times x is exactly the factors of 2x squared. 3 times 1, but not in that order. Guess and check. 3 times 1 are exactly the factors of 3. And positive 3 and negative 2 is exactly where that positive x came from. And that is fully factored. All 3 degrees still there. And that all came down from that first step, which was synthetic division.